Hello everyone. In this video, I am solving problems related to finding matrix of linear transformation. So you know that matrix of linear transformation varies with respect to the given basis. If it is a standard basis, then you have to check where the standard vectors go after applying the transformation. If the basis is other than the standard basis, then first you have to represent how the coordinates of any vector a comma b in R square is represented with respect to the given basis. So first see the problem. Consider f from R square to R square given by this is the linear transformation. You have to find matrix of A with respect to standard basis. This is the first question. So standard basis of R square is 1, 0 and 0, 1. Okay. Now matrix of F is nothing but where these standard basis vectors go after applying the transformation, that is f of 1, 0 and f of 0, 1. What is this value? Put it over the transformation. X is 1, y is 0. So you'll get 3, 2 and f of 0, 1 is 4, minus 5. Now matrix of F which is equal to A, that is equal to, you have to write, this is where I cap goes to after applying the transfer. This is where J cap goes to after applying the transformation. Now you have to write these vectors column wise. 3, 2, this is the new position of I cap, and 4 minus 5, this is the new position of J cap. This is called as matrix of the transformation with respect to the standard basis. So instead of the transformation, you can use this matrix of transformation to represent the given transformation. See, for example, if you want to check where 1, 2 goes to after applying the transformation, that is, put x equal to 1, y equal to 2, 8 plus 3, 11, here 2 minus 10 minus 8. So instead of writing this transformation algebraically, I can multiply the vector 1, 2 by this matrix to the left. So that also gives you 3 plus 8, 11, 2 minus 10, that is minus 8. So this is a representation of the given transformation using matrix. Now the second question is, find matrix B of the same transformation but with respect to some other basis. That was the standard basis. Now here the basis is S is equal to set containing 1, 2 and 2, 3. Okay. Now 1, 0 and 0, 1. The vectors 1, 0 and 0, 1, where they go to after applying the transformation, that is with respect to the standard basis. Now you have to check where 1, 2 and 2, 3 go to after applying the transformation. That you have to find out. But 1, 2 and 2, 3, this gives you a new coordinate system where every vector is a linear combination of these two vectors, scaling and adding these two vectors. Therefore, you have to find out coordinates of any vector. So first you have to get coordinates of a any vector in R square with respect to the basis. Yes, take any vector in R square as a b. You have to write it as a linear combination of 1, 2 and 2, 3. Okay, so that x and y are called as coordinates of that vector in R square with respect to the basis. Yes, because when you change the basis, its coordinates also changes. So this gives you the system x plus 2y equal to a and 2x plus 3y equal to b. I have made a separate video on matrix of linear transformation where I had explained the theory, how the coordinate system changes when you change the basis. You watch that video to get the intuition behind matrix of linear transformation. Now you have to solve this system. This gives you 2x plus 4y equal to 2a, and here 2x plus 3y equal to b. Now subtract these equations, so you will get y equal to 2a minus b, and here x equal to a minus 2y, that gives you a minus 2 into 2a minus b. So x equal to a minus 4a plus 2b. So x equal to 2b minus 3a. This is the value of x. Therefore, coordinates of any vector a, b in R square with respect to the basis S is given by 2b minus 3a and 2a minus b. The same vector a comma b is called like this in R square with respect to this basis S. This you have to remember now. After finding how the coordinates of any vector is represented with respect to S, now you find out where these, because 1, 2 and 2, 3, these are with respect to our usual basis, T of 1, 2 or f of 1, 2, where it goes to after applying the transformation. F of 1, 2 is nothing but 4 to the 8 plus 3. That goes to 11 minus 8. 11 minus 8. Okay, that is f of 1 2. Next, f of similarly 2 3. F of 2 3, where it goes to after applying the transformation. Here 3 2s 6 plus 4 3s 12, 18. So this gives you 18, comma, put x equal to 2, y equal to 3 here. Okay, 2 2s are 4 minus 15 minus 11. So this gives you minus 11. So these are the vectors in our standard coordinate system, but we need the coordinates of these vectors with respect to the basis S. This is where 1, 2 goes to in our standard coordinate system. But now coordinate system is different, where I cap role is played by 1, 2 and j cap role is played by 2, 3. I cap goes to, now 1, 2 goes to this position, but this position is in our coordinate system as per the standard coordinate system, because transformation is given in terms of the standard coordinate system. That's why you have to convert now. So coordinates of 11 minus 18 are, how to find that? That is using this expression 2b minus 3a. b is minus 8, a is 11. So minus 16 minus 33, minus 16 minus 33 minus 49. Similarly, 2a minus b, that is 22 minus of minus plus 30. So the same vector is called as minus 49, 30 with respect to the basis yes. So that is nothing but it is minus 49 times 1, 2 plus 30 times 2, 3. Okay, this is how to scale the vectors, these two vectors, to go to the position 11, minus 8, which is same as minus 49, 30. Similarly, get the coordinates of these vectors. So use this formula 2b minus 3a, that gives you minus 22, this is minus 22 minus 54, that gives you minus 76. Okay. Similarly, next here 2a minus b, 36 plus 11, that gives you 47. Now you have to form the matrix of the basis with the matrix of the linear transformation, that is B with respect to basis yes. So this is where the basis vector 1, 2 goes to after applying the transformation, but it is with respect to our system. As per the basis system, its coordinates are minus 49, 30. So it goes to minus 49, 30 and 2, 3 goes to 18, minus 11, but 18, minus 11 is in our system. As per the basis yes, new basis yes, it goes to minus 76 and 47. This is the matrix of linear transformation with respect to basis yes. Now two matrices you got. This is with respect to standard basis. A and B are called as similar matrices because they represent the same transformation. You know that similar matrices will have the same characteristic polynomial. It has the same minimal polynomial. Then determinant value is also same. You can check with these two matrices A and B because they represent the same transformation but with respect to different bases. Now see one more question. Let V equal to, it is vector space of functions with the basis the S is equal to sin t cos t e to the power 3t. This is the basis of a vector space of all functions. So now D is a mapping from V to V this be a differential operator. You know that differential operator is a linear transformation. This is nothing but gives you the derivative of the function. You have to find the matrix of D with respect to the basis. Yes. Okay, so first let us find out where these basis vectors will go after applying the transformation. Derivative of sin t is equal to cos t, derivative of cos t equal to minus sin t, then derivative of e to the power 3t equal to 3 into e to the power 3t. Okay, now you have to write these values in terms of the basis vectors, that is 0 into sin t, because there is no 0 sin t term, plus 1 into cos t, plus 0 into e to the power 3t, because there is no e to the power 3t term. Here it is minus 1 into sin t, plus 0 into cos t, plus 0 into e to the power 3t, right, in this order what is given in the question. Here it is 0 into sin t, plus 0 into cos t, plus 3 into e to the power 3t. Now list out all the coefficients. So that gives you the matrix D of the transformation. So matrix D you can name, or else you can name it as A also. Okay, D equal to, write all the coefficients here column wise: 0, 1, 0, minus 1, 0, 0, then 0, 0, 3. This is the matrix of the given linear transformation with respect to the basis. Yes. See, third problem, let S equal to, this is now the basis. Basis is given where V is a vector space of functions from R to R. D be the differential operator on R, which is given by df by equal to df by dt. You have to find the matrix of D with respect to now this basis. This is different basis. Earlier you had the basis sin t, cos t and e to the power 3t. Now here they have given a different basis for the space of functions from R to R. So, and the linear transformation is the differential operator. So, first to find out where these basis vectors will go after applying the transformation. Derivative of e to the power 3t, then derivative of t into e to the power 3t, derivative of t square into e to the power 3t. That is the thing you have to do when you are finding the matrix of the transformation with respect to the given basis, where the basis vectors will go, that you have to find out. Then you have to write the where these vectors will go, that answer in terms of the basis vectors. E to the power 3t derivative with 3 into e to the power 3t. Here product rule, 2 into 3 into e to the power 3t plus e power 3t into 1. Next here also product rule, t square into 3 into e to the power 3t plus e to the power 3t into 2 into 2. Now this can be written as in terms of this 3 e to the power 3t plus 0 into t e to the power 3t plus 0 into t square e to the power 3t, because there are no those two terms. Here now there is 1 into e to the power 3t plus 3t into e to the power 3t plus no t square term, t square into e to the power 3t. Now here no e to the power 3t term, 0 e to the power 3t plus 2 into t e to the power 3t plus 3 into t square into e to the power 3t. Write the coefficients column wise. So matrix of this transformation with respect to the given basis, you can write D is equal to, now this is 3 0 0 3 0 0, next 1 3 0, next 0 2 3. So this is the required matrix. Now see fourth problem. Here a matrix is given and a basis is given. You have to find the matrix that represents this mapping A relative to basis. Yes, instead of giving the transformation algebraically, they had given you the matrix. You know that every matrix can be viewed as a transformation. Here it is 3 by 3 matrix from R cube to R cube, given by A T of u equal to A into u. This is the transformation associated with the given matrix A. Okay. Now you have to find out the matrix that represents this transformation relative to this basis. So whenever other than standard basis is given, then you have to first find out coordinates of vector in R cube with respect to this basis. So take any vector from R cube, A, B, C. I have to find the coordinates of these vectors with respect to the basis, yes. So how to do that? X into 1, 1, 1 plus y into 0, 1, 1 plus z into 1, 2, 3. So you have to solve this system. This gives you x plus z equal to A, then x plus y plus 2z equal to B, then x plus y plus 3z, x plus y plus 3z equal to C. This is the system. Now you have to solve this system. So to solve this system, you can write the augmented matrix A comma B. Augmented matrix is 1 0 1 A, then 1 1 2 B, coefficients 1 1 3 and C. Reduce it to the echelon form, Gauss elimination method kind of thing. 1 0 1 A, then 0 1 2 minus 1 1 B minus A, R2 changes to R2 minus R1, R3 changes to R3 minus R1, that gives you 1 minus 1 0 1 3 minus 1 2 C minus A. Again you have to reduce this value to 0, that is R3 changes to R3 minus R2. So 1 0 1 A, then 0 1 1 B minus A, then 0 0 2 minus 1 1, then C minus A minus B plus A. So that is C minus B. Okay. Now you will get the equivalent system. It is in the Gauss elimination form, upper triangular matrix form. So z equal to C minus B, then y plus z equal to B minus A, and x plus z equal to A. So y equal to B minus A minus C plus B. So y equal to 2B minus A minus C. X equal to A minus C plus B. So x equal to A plus B minus C. So coordinates of any vector A, B, C with respect to the basis S given by x is A plus B minus C. Then y is 2b minus a minus c, z is c minus b. This is the first thing you have to do whenever other than the standard basis is given. How any vector in R cube is represented with respect to that standard basis, that we have to find first. After having this, now check where this basis vector will go to, because after applying this transformation, basis vectors will go to a new vector that is in our system, our standard coordinate system, because all these basis vectors are in terms of our standard coordinate system. Later we have to convert what it is called as in the new basis system. So that is what the main thing behind finding the matrix of the transformation with respect to some other basis. So first you find out what is T of 1 1 1. This is nothing but AU, A into, what is this transformation represented by this matrix? A into U. So A is 1 minus 2 1, 1 minus 2 1, 3 minus 1 0, 1 4 minus 2, where it goes to 1 1 1, where this vector goes to after applying the transformation. So you can check this goes to 0 2 3. So next, similarly, T of 0 1 1, this is another vector of the basis, same way, 1 minus 2 1, 3 minus 1 0, 1 4 minus 2, where this vector goes to after applying the transformation, it goes to minus 1 2. Okay, next T of last 1 2 3, this is equal to 1 minus 2 1, 3 minus 1 0, 1 4 minus 2, where this vector goes to 1 2 3. After applying the transformation, you can simplify it. It goes to 0 1 3. All these are as per our standard coordinate system. So you know now what is the coordinate of any vector in R cube with respect to the standard basis ABC. It is with respect to the basis S is given by this. This is the coordinate of any vector with respect to S. Now apply that here. So coordinates of this vector, where this vector gets mapped to coordinates are given by A plus B minus C. So 2 minus 3 minus 1, 2b minus A. This is A, this is B, this is C. A, B, C. Apply that formula here. 2b minus A minus C, that is 4 minus 0 minus 3 1. Next C minus B 1. This is what it is called in the new coordinate system. minus 1 1 1. Now this vector is minus 1 minus 1 2. It is called as, in the new coordinate system with respect to basis, yes, what it is called as, apply here, minus 1 minus 1 minus 2 minus 2 minus 4. Then similarly you can check, this is minus 3 and this is 3. And the third vector, this vector 0 1 3, this vector 0 1 3, it is called as minus 2 minus 1 and 2, minus 2 minus 1 2. Okay, therefore the matrix of the given transformation with respect to the basis S is given by minus 1 1 1, minus 4 minus 3 3, minus 2 minus 1 2. So this is the required matrix. See, fifth problem. Let G be a linear operator on R cube given by, this is the linear transformation. You have to find matrix of G relative to the standard basis. First, you know standard basis vectors are 1 0 0, 0 1 0, 0 0 1, where these vector goes to after applying the transformation here. X is 1, this is 0 1 3, then G of 0 1 0 equal to y is 1, so 2 minus 4 and 0, and G of 0 0 1 equal to z is 1 0 and 0. Okay, therefore matrix of this linear operator with respect to the standard basis, I'll name that matrix as A, is given by 0 1 3, 2 minus 4 0, 1 0 0. No conversion needed because our usual basis is the standard basis itself. So where the standard basis vector go after applying the transformation, that you have to find out, and you have to write all those vectors column wise. That you have to remember, not row wise, it is column wise. Next, you have to find the matrix of this transformation with respect to this basis. This is other than the standard basis. So whenever any basis other than the standard basis is given, first you have to find out coordinates of any vector A, B, C in R cube relative to the basis, yes, because the same vector is called in some other way with respect to this basis. Yes, let us find out what it is. A, B, C equal to x times. Every vector is a linear combination of these three vectors. So 1 comma 1 comma 1 plus y into 1 comma 1 comma 0 plus z into 1 0 0. Okay, you get a system of equations, x plus y plus z equal to A, then x plus y equal to B, then x equal to C. So when x equal to C, y equal to B minus C, and z equal to A minus B plus C, and x is minus C. So z equal to A minus B. Therefore coordinates are, x, y, z, they are nothing but C, B minus C, A minus B. So whenever you have A, B, C in R cube with respect to that standard basis C with respect to S, the same vector is called like this. It is written like this. So keep it aside. Now you have to find out now matrix of the transformation with respect to S. First find out where these basis vectors will go after applying the transformation. So I will write the transformation here, J of x comma y comma z equal to x 2y plus z, 2y plus z, x minus 4y and 3x. Now where these basis vectors will go, 1 comma 1 comma 1. X is 1, y is 1, z is 1. So it is 3 comma minus 3 comma 3. Next t of 1 comma 1 comma 0. This is another basis vector. So 2 comma 1 minus 4 minus 3 comma 3. Okay. Next t of 1 comma 0 comma 0. This goes to, this is 0, this also 0, 1, 0 here, and here 1 because x is 1, 0, 1, 3. So now you have to find out coordinate vectors. Coordinate vectors are here 3 minus 3, 3. Where it goes to? See, 3 minus 3, 3 is called as. Apply this formula. 3, B minus C. This is A, this is B, this is C. B minus C. So minus 6 and A minus B. 3 minus of this is 6. Similarly, 2 minus 3, 3 goes to 3, B minus C minus 6 and A minus B, that is 5. Then 0, 1, 3 goes to C is 3, B minus C minus 2, A minus B minus 1. This is minus 2. See, that means this is 3 times 1 comma 1 comma 1 minus 6 times 1 comma 1 comma 0 plus 6 times 1 comma 0 comma 0. See, that's why the coordinates are 3 minus 6 and 6. Okay. Hence, matrix of G with respect to you can write like this. Matrix of G with respect to the basis S is given by, write all these coordinate vectors column wise. 3 minus 6, 6, 3 minus 6, 5 and 3 minus 2 minus 1. And one more thing is given here. You have to verify G of V equal to the G of V transformations. So you know that G of V means what? G means this is matrix with respect to the basis. Yes. V means it is coordinator vector of any vector V with respect to S. Okay. Find out this. 3, 3, 3 minus 6 minus 6 minus 2, 6, 5 minus 1. This into coordinate vector of any vector with respect to S, we got it as C, B minus C, A minus B. C, B minus C, A minus B. Simplify this, multiply. Okay, this gives you 3C, 3C plus 3B minus 3C, and here minus 6C minus 6B plus 6C minus 2A plus 2B. Next 6C plus 5B minus 5C minus A plus B. So after simplifying this, you will get 3B and minus 6C plus 6C cancels here. So it is minus 4B minus 2A, and here it is C plus 6B minus A. Now you have to find out G of V of with respect to S. First you have to find out G of V. Okay, coordinate vectors of G of V with respect to S you have to find out. First let us find out G of V, because if you have any vector V, its coordinate vectors are always denoted using this square bracket. You can write below the basis also as S. First let us find out G of V. What is G of V? You know that if A, B, C is the given vector, G of V is here, the transformation. Okay. So G of A comma B comma C, which is equal to, where this goes to, replace X by A, Y by B, Z by C, 2B plus C. So this is 2B plus C, comma, next is here A minus 4B, then 3A. A minus 4B, then 3 into A. Get coordinate vector of this G of V with respect to S. So what is the coordinate vector? C, we got it as B minus C, A minus B. This was coordinate vector with the, of any vector with respect to the standard base, with respect to the basis. Yes. So you get here, apply here. This is A, this is B, this is C. So you will get 3A, then B minus C. A minus 4B minus 3A. So you will get A minus 4B minus 3 into A. Then A minus B, 2B plus C minus A plus 4B. So simplify this. 3A, A minus 3A is minus 2A. So minus 2A minus 4B. Then here it is 6B plus C minus A. Now compare this with the given, this first one. See, and here you have plus 3C, 3B minus 3C plus 3A minus 3B. So 3C minus 3C cancels, 3B minus 3B cancels, so remaining is 3A. This must be 3A. So hence you will get these two are equal. So you will have G and coordinate vector of v is same as g of v with respect to the basis? Yes. See now last problem. For each of linear transformations L on R square, find matrix of A with respect to standard basis. Standard basis of R square is 1, 0 and 0, 1. This is standard base. See L is defined by L of 1, 0 is 2, 4. L of 0, 1 equal to 5, 8. How to write the matrix of this L? That is where these standard basis vector goes to. That is directly given. Write it as columns 2, 4 and 5, 8. This is matrix of L. Next, L is rotation in R square counterclockwise by 90 degree. So, this is x-axis, positive y-axis, negative x-axis, negative y-axis. Counterclockwise, anti-clockwise by 90 degree. So, after applying the transformation, what happens to 1, 0 and 0, 1? These are the basis vectors I cap and j cap. I cap comes here and j cap comes here. This is the new position of I cap and j cap after applying the transformation. I cap comes to the position 0, 1 and j cap comes to the position minus 1, 0. So, matrix is given as 0, 1, minus 1, 0. Or else you can write it like this. The transformation is represented by minus y, x. So, 1, 0 goes to 0, 1 and 0, 1 goes to minus 1, 0. The same you can write column wise. Next, L is a reflection in R square about the line y equal to minus x. How to write the reflection in the form of a linear transformation algebraically? T of x, y equal to minus y, minus x. So, this is how to write the reflection in R square about the line y equal to minus x. So, T of 1, 0 goes to 0, minus 1. T of 0, 1 goes to minus 1, 0. Therefore, what is the matrix of this transformation? 0, minus 1, minus 1, 0. So, this is how to get the matrix of the transformation with respect to the standard basis. I hope you understood the concept. Whenever standard basis is given, you directly find out where these basis vectors go after applying the transformation. If basis other than the standard basis is given, first you find the coordinates of any vector with respect to that basis. Then you find out where these vectors will go after applying the transformation. Then convert those vectors to the vectors in the new coordinate system using this coordinate vectors. So, this is how we get the matrix of linear transformation. I hope you understood the concept. Thank you for watching.